AB Calculus homework help on indefinite integrals. I assigned today these problems 1 through 12, and I'm going to go over a few of these. And basically, what we do, we're going to take number 2 first. We have the integral of x to the 5th power dx. And what happens, this symbol here is an integrand, and this means it's an instruction to integrate. And so what we do for that is we can use our power rule of anti-differentiation, and our answer to this is going to be x to the 5 plus 1, or 6th power, and we're going to divide by what we raised, the power 2, by 6. And then we have to add the unknown but necessary constant of integration c. And so sometimes you'll see this written as 1/6 x to the 6th power plus c. Okay, that's problem number 2. I also agreed to do problems 8 and 9, and here we are. We have number 8, the integral of this quantity here, and what I'm going to do is separate all these into separate integrals. And while separating, I'm going to take that coefficient outside. So this 3/4 x to the 5th, I'm going to say 3/4 the integral of x to the 5th dx. And next, plus, we're going to take the 5/5, or 5/3 rather, out of the integral there. We have x squared, and then finally minus, I'm going to take this 1/2 outside, 1/2 integral of x. And these are all going to be times dx. I forgot that one. So that'll be dx minus 1/2 integral of x dx. So this so far is just a rewrite. Okay, and next we're going to use our power rule of integration. So we have 3/4 times, we take x, we're going to have x to the 6th power, and we're going to divide, I'm just going to put this down here, divide by 6. So we divide by the power that we raise the variable to, plus we have 5/3, and then we have x to the 3rd power, and we're going to divide by 3. And then we have minus 1/2, we're going to have x squared, and we divide by the power that we raised to, which is 2. And then we have, finally, the constant integration c. Now we're going to simplify all this and get a better looking answer, we hope. So in the numerator we have 3, in the denominator we had 4 times 6, which is 24, and 8 goes into 24, 3 goes into 24 8 times, so we're going to have 1/8 x to the 6th power, and then over here, the next term, we're going to have 5 over 3 times 3, or 9, so we're going to have plus 5/9 x to the 3rd power, and our last term is going to be minus 1 over 2 times 2, and 2 times 2 is 4, so minus 1/4 x squared. And then we say plus c. And we know we're on the right track if we differentiate and get what we originally had. Okay, if we take 6, if we take 1/8 x to the 6 multiplied by 6, we'll have 6 over 8, or 3/4. Okay, then for this one, we have 3 times 5, which is 15. 15 divided by 9 is 5/3. And for this last one, we're going to have 2 times 1, which is going to be minus 2/4, or 1/2. So this all checks out. That looks good. Now for number 9. Again, we have a similar type of problem to number 8, except that we have the constant pi. Well, understanding that pi is a constant enables us to split up this integral by taking pi on the outside, and we have x remaining. We distribute this dx, right? X dx, and then plus, we're going to have 1 over pi. Well, 1 over pi is also a constant. So we have 1 over pi times the integral of 1 times dx, which is dx. So now, working below, we're going to have pi, and what's x? What's the integral of x dx? It's going to be x squared over 2. And then we have plus. We're going to have dx, that's just going to be x, but we're going to have 1 over pi times x, and then that's going to be plus the constant integration c. And finally, there's not a whole lot left to do to rewrite this thing. We're going to have pi over 2 x squared plus, we could write this a bunch of different ways. We could write this as x over pi plus c. And then we could go backwards to see if we get the same thing, right? We're going to have, if we take the derivative of this, we're going to cancel, the 2 will cancel out the 2. We'll have pi x, yeah. And then if we do this if we take the derivative of x, we'll get 1, and 1 over pi. So this is going to be our answer to problem 9. And also, I just want you to look at problems 10, 11, and 12, which are also part of your assignment. Good luck, and thanks for viewing.